We're going to begin the technique of separation of variables, which is a trick used to solve differential equations. And if you remember, the differential equation that we came across in E&M has the form of a constant times a function plus a constant times its first derivative equals 0. And we usually see it written in math classes like this. I'm going to use a derivative with respect to x. So we have y prime minus 2y equals 0. And the question we ask is, what is a function that satisfies this equation? And the answer that I'm proposing here, I'm just kind of handing that to you, is the function y equals some constant c times e to the 2x. And the first thing we're going to do is we're just simply going to say, what do we mean by satisfies equation? We're going to demonstrate that it does by simply plugging it into the original equation. So what I'm going to do is I'm going to say c e to the 2x prime minus 2 c e to the 2x. And so let's take that derivative. When we take the derivative, that's going to be c times 2e to the 2x. So that's this part right here. And we'll subtract off the 2ce to the 2x. And of course, we do find out that it equals 0. So this is in fact, this in fact does satisfy the equation. A couple pieces of terminology. The function that satisfies this differential equation, as we call it a differential equation because it's an equation that has derivatives or differentials in it. That's literally why it's called the differential equation. And so this function that satisfies the differential equation, we call it a solution. And the process that we use to discover what this function is called solving the differential equation. And usually what we have to do is some combination of algebra and calculus. So our goal is to come up with the function that satisfies this particular differential equation, and we call that solving it. So I've got you started off here with the technique, and I want to give you the name of this technique, which I have up here. It's called the technique of separation of variables. And what that means is I'm literally going to separate out my x terms and my y terms, and I'm going to use that to solve. So first, I take my original equation, and I'm going to rewrite it using differential form. So I have dy over dx minus 2y equals 0. Next, I'm going to isolate the derivative by itself equals the rest of the stuff on the other side. And now, on the left side, I'm going to have all of the y stuff. And on the right side, I'm going to have all of the x stuff and the constants. Okay. So here's what I'm going to do next. I am now going to integrate both sides. That is the next step in the process of solving these equations. So step 1, take your equation, write it in derivative form like this. Next, separate your variables. Third, set up your integrals, and now we're going to integrate. This is going to be the natural log of y equals 2 times x, and what we're going to do is we're going to go ahead and put the letter c right here. Okay. Next, we're going to exponentiate both sides. So e to the natural log of y equals e to the 2x plus c. Okay. So that means, as we rearrange, that's going to be y equals, and I'm going to split this up into e to the c times e to the 2x. Now that's just a terrible name for a constant, e to the c. So since this is a constant in the first place, instead of calling it e to the c, I'm just going to rename this thing. I'm just going to say y equals a e to the 2x, and I see that that indeed is the answer. Okay, so this is the very first example of separation of variables. And what we're going to do in the next couple pages is we're just going to practice this process and practice this process. I want to lay out, dang it. I want to lay out a couple of rules in the order of how we do this. So, step 1, okay, rewrite. That's bad handwriting. So, step 1, rewrite using dy dx. Step 2, separate. Step 3, write integral signs. Step 4, take antiderivatives. Step 5, solve for c. Step 6, write y of x, and we're done. So right here, if you want to kind of be clear, there's step 1, there's step 2, there's step 3, there's step 4, here's step 5, and there's your step 6. And this is what we're going to be practicing in our next videos.